I'm Anil Kumar, and in this particular video we will take some examples of half angle and show how to find solution of linear trigonometric equations. Now let me take two examples, one with cosine. So let's have cosine x over 2 equals to square root 3 over 2, and then we'll solve for sine x over 2 equals to some value where we can take the help of calculator. So let me write a value like 1.2678. Okay. Now you can also pause the video at this stage and write down your solutions. We need to solve these equations where theta is between 0 to 2 pi. Since I have taken x as my variable, let me change it to x. So x is between 0 to 2 pi. So the very first step should be, when x is between 0 to 2 pi, x by 2 should be between what? We have to divide them by 2. So we get x by 2 should be greater than equal to 0 but less than equals to 2 pi divided by 2, or pi. So that is the very first step. Now let us solve for cos theta equals to square root 3 over 2. So we'll take normally the positive value and find the acute angle. So square root 3 over 2 reminds us of special triangle. So let's sketch this special triangle. It's always better to do it. For me, it's a reminder so that you can remember this, right? So we have this angle as pi by 3. The sides are 1, 2 square root 3, and this is pi by 6. For the right triangle, which is pi by 3, pi by 6, pi by 2, or 60, 30, 90. Now cos theta or cos alpha, which is going to be 3 by 2, will be for particular angle which is pi by 6, correct? So in quadrant 1 we are trying to find the related acute angle. So related acute angle, which is going to give us square root 3 over 2 as the value, this over that, is pi by 6. So we get, let's write down, cos alpha, the acute angle, will be square root 3 over 2. It means alpha is equals to pi by 6. Now, we are given the domain of this angle between 0 to 2 pi. Now in 0 to 2 pi, cos is going to be positive only for quadrant 1, right? So if you apply the rule, cos is positive for quadrant 1 and is positive in quadrant 4. Since our domain is restricted to 0 to pi, we cannot consider this value, right? We cannot consider 2 pi minus pi by 6 as our solution. That is critical to understand. Okay, so what we get here is that x by 2 is equal to only pi by 6, or x is equals to 2 times pi by 6, which is pi by 3. You understand? So that is the solution for this particular question. Now think about it. If I would have included this answer, which is 2 pi minus pi by 6, or it is 11 pi by 6, in that case, think like this. Let me do it on the side. If I include the angle 11 pi by 6, which will be kind of like this, do you understand? Correct? In that case, this is x by 2. In that case, x will be 11 pi by 6 times 2, correct? Or you could write this as 11 pi by 3. That will make it more than 2 pi. So you'll go out of domain. So that answer is not in your domain. Therefore, we have only one solution here. So our answer for the given question is x is equals to pi by 3. Now remember one more thing. If we have x by 2, and if I have to sketch this graph, in that case, how will my graph look like? The graph will indeed be like this, where the time period has been stretched to 4 pi, right, from 2 pi. So the 2 pi value, I wanted to write 4 pi, okay. So will be 4 pi. 2 pi for, this is the graph for cos of x by 2, right? Now here, this is 2 pi. So you can see the only solution, positive solution, is in the first quadrant. You get the idea. So that is how you should be doing it. Now let's begin to solve the next question. You know the fundamentals now, so you can also write down the answer. So this time let's look into the graph first. So the graph of sine x by 2 will be similar to sine x, with a major change that the time period is stretched, and instead of 2 pi it has become 4 pi, right? So 2 pi is right there. When we are looking for a positive solution in this case, you do get two solutions. Do you see that? You do get two solutions. So you are expecting two solutions. Reason is very clear. Reason is that when you are looking into the quadrants, then in the domain of 0 to pi, sine is positive in quadrant 2, right? So it is positive in quadrant 1 and 2. Therefore, you expect two answers. You get the idea, correct? Now let us solve this. So we have sine of x by 2 equals to 0.2678. So we will solve for sine alpha, find acute angle first, equals to 0.2678. So alpha equals to sine inverse of 0.2678. Using calculator, we'll find this answer. Sine inverse of 0.2678 equals to, alpha for us is 0.2711. So we got one solution. This is for quadrant 1. Now since sine is positive in quadrant 2 also, we have to write the second solution. Why are we doing it? We know x is greater than equals to 0 to 2 pi, that's our domain. For x by 2, the domain is going to be 0 to pi. So within 0 to pi, sine is positive twice. Therefore, we have two solutions. So let's write down what is x by 2 equals to. So one of the solutions is 0.2711. The other will be pi minus 0.2711, which is, we can do 3.14 minus 0.2711, right? 3.14 is the pi value, which we can take if we are looking for one decimal place accuracy. 2.86. Is that okay? Now dividing by 2, we actually get the x value. So let me divide this by 2 first. So the second answer is 1.43. Let's write it to two decimal places, and the first one will be 0.2711 divided by 2 equals to, in decimals, 0.1. We can write this as 4, round to second decimal place. So that is the value of x. You will see that both these values are within the domain 0 to 2 pi, correct? So that is how you can find the solution for a quadratic equation where the argument, the angle involved, is less than, a fraction, right? So the time period is more than 2 pi. That's another way of putting it up, right? So in that case, we have these kinds of situations. So most important thing which you have to consider is the domain itself. Consider the domain always to write all the possible solutions within the given domain. I hope that helps. Thank you.